We will now discuss a matrix multiplication property, that is left distributive law, where, as you can see over here, we have, if you have A times B plus C, then you just take the A and multiply with the B, plus take the A and multiply with the C. So A times B plus A times C will be equal to A times B plus C. And then here down we have a question, that is check the above property for matrices A, B and C given below. So basically we are given three matrices A, B and C here, and we have to prove this distributive law, is it true or not. Okay, so first for the solution we'll start by finding the matrix A times B plus C. Alright, that is this part here. We'll first work on the left hand side, then we'll work on the right hand side. So now first we'll work out what's inside the bracket, and that's B plus C. So we'll first work on B plus C here. The matrix B is 1, 2, 1, 0, 4, 8, 3, 1, 2, plus we have the matrix C, which is 0, 1, 3, 10, 5, 7, 0, 0, 1. And now we'll add these two matrices here. So each element will in matrix B will be added to each element in matrix C. Therefore, we'll have it like the first element here will be added to the first element here. So it will be 1 plus 0. And then the second element here, that is the second row, first column element, that's, you can say this is B21 plus C21. So that's 0 plus 10. And then we'll have here 3 plus 0. And then here will be 2 plus 1, 4 plus 5, and 1 plus 0. And this side will be 1 plus 3, 8 plus 7, and then we have 2 plus 1. Now we add all of that, we get here 1 plus 0 is 1, then we have 0 plus 10 is 10, and 3 plus 0 is 3, and then here we have 2 plus 1, 3, 9, 1, then we have 4, 15, 3. So that's B plus C now, and what we have to do now is we have to multiply A times B plus C. So A here we have 2, 0, 3, and then 1, 4, 6, and B is 1, or B plus C, sorry. So this one here is B plus C, that's 1, 3, 4, 10, 9, 15, and then we have 3, 1, 3. Now let me take it to the next page so we can do it there. Okay, so now first we have to check whether we can do this multiplication or not. So we write the sizes of these two matrices here. That's, this one here is 2 rows times 3 column, and here we have 3 rows times 3 column. And as you can see, these two numbers here are equal, so this matrix multiplication is possible. Okay, now then let's work on it. So what we do here now is we take the first row here and we multiply it to the first column here. So we have 2 times 1, so the first element with the first element there. So 2 times 1 plus 0 times 10 plus we have 3 times 3. Again, I think I'll fall short of space, so I shouldn't have written it there. Okay, so now here, let's go on with the first row. We'll take the first row here and we'll do it now with the second column here. So we have 2 times 3 plus 0 times 9 plus 3 times 1. Again, we take the first row and now we go with the third column. So we have 2 times 4 plus 0 times 15 plus 3 times 3. Okay, now we go with the second row this time and we do with every column again of the second matrix. So with the second row here we have 1 times with the first. So now what we're doing here, maybe I'll use a different color so it's more easy for you to see. So what we're doing now is, sorry about this. Okay, so what we now do is we take the second row here and we start from the first column. Okay, we start from the first column, and so we have 1 times 1 plus 4 times 10 plus 6 times 3. And then again, now we keep taking the second row, but now we go to the second column. So 1 times 3 plus 4 times 9 plus 6 times 1. And then here we have second row with the third column now. So we have here 1 times 4 plus 4 times 15 plus 6 times 3. Okay, now here, so we have here 2 plus 0 plus 9. Then we have here 1 plus 40 plus 18. Then we have 6 plus 0 plus 3, 3 plus 36 plus 6 here, and then we have here 8 plus 0 plus 9, and 4 plus 60 plus 18. So one might think that why am I breaking down into so many steps this one, right? The multiplication. There are 2 reasons for this. One is that so that you understand better when you look at it second time, of course. And the second reason is that you have to do something similar in your exams. So maybe out of these 2 steps, you can skip 1 step, but at least one you have to write. Maybe better go for this one. You have to write this one in your exam, and then you can just write it, all the addition, the final answers. That is, you can go from this step to this step, leaving this one here. But then you have to do this because there are marks for steps in the exam. So yeah. Now here, so if you add 2 plus 9, you get 11. And then here 6 plus 3 is 9. And then you have 17. And here you have 59, 45, and 82. Okay, so that's the answer to the first part. Now we need to finish solving, right? That's no need of writing that, is here. So we kind of finished solving a times b plus c, the left hand side. Now what we're supposed to do is we have to find a times b plus a times c and then compare these two answers whether they're equal or not. So first what we do is we do, of course, a times b, and then we'll do a times c, and then we'll add them. So a times b, so here you have a is 2, 0, 3 and 1, 4. I would again like to take this to the other page because I wouldn't have enough space here to solve everything. Okay, so we have here 1, 4, 6. That's a times b is 1, 2, 1, 0, 4, 8 and 3, 1, 2. Okay, so that's now here. If you want to recheck, we have this matrix is a 2 by 3 matrix and this one here is a 3 by 3 matrix. So yeah, they are equal, they can be multiplied. Okay, now let us do the multiplication. So here we have 2 times 1. So we go with the first row and then we do one by one all the columns here. So we go with the first row with the first column now. So we have here 2 times 1 plus 0 times 0 plus 3 times 3. And then we have 2 times 2 plus 0 times 4 plus 3 times 1. And then we'll go with 2 times the third column now, 1 plus 0 times 8 plus 3 times 2. Okay, now we go with the second row and again with all the columns now. So we have here 1 times 1 plus 4 times 0 plus 6 times 3. Then we have here 1 times 2 plus 4 times 4 plus 6 times 1. And then we have 1 times 1 plus 4 times 8 plus 6 times 2. Now we have 2 plus 0 plus 9, and here 1 plus 0 plus 18. And then we have 4 plus 0 plus 3 and 2 plus 16 plus 6. And then here we have 2 plus 0 plus 6 and 1 plus 32 plus 12. Okay, now we add all of them and we'll have here 11, 19, 7, 24, 8 and 45. So this is just a times b. Now we have to find out a times c. So let's work on a times c. A is 2, 0, 3, 1, 4, 6 and c is 0, 1, 3, 10, 5, 7, 0, 0, 1. If you multiply this 2, you will have here again, we go with the first row and first column now. So 2 times 0 plus 0 times 10 plus 3 times 0. And then we go with the first row and second column now. So here we have 2 times 1 plus 0 times 5 plus 3 times 0. And then first row with the third column now. We have 2 times 3 plus 0 times 7 plus 3 times 1. Okay, now we go with the second row. I'll use a different color. So now we go with the second row and the first column. So 1 times 0 plus 4 times 10 plus 6 times 0. Then 1 times 1 plus 4 times 5 plus 6 times 0. And then we have 1 times 3 plus 4 times 7 plus 6 times 1. Now multiplying and writing them down, you will have here 2 times 0 is 0, 10 times 0 is 0, plus 3 times 0 is 0, and here you have 0, 40 plus 0, then you have 2 plus 0 plus 0, and 1 plus 20 plus 0, and 0 plus 0 plus 3, and then you have 3 plus 28 plus 6. Okay, now here after you add them you get 0, 2, 9, 40, 21, and 37. Now what we do is we take the A times B that we got and we add it to the A times C that we got. So A times B, we got it as 11, 7, 8, and here 19, 24, and 45 times, plus we have A times C, which is 0, 2, 9, 40, 21, 37. Now we have to add this both here. So 11 plus 0 is 11, 7 plus 2 is 9, 8 plus 9 is 17. And then you have 19 plus 40 is 59. 24 plus 21 is 45, and 45 plus 37 is 82. Okay, so that's the final answer for the right hand side. Now, are they equal? So we have here 11, 9, 17, 59, 45, 82. And here we got the answer to the right hand side. Here 11, 9, 17, 59, 45, 82. So they are equal because each element of each matrix is equal to the other element. So we cannot just say that, we have to write that down in a formal way. So what we write it is, we say since the I, jth entry of the matrix A times B plus C is equal to the I, jth entry of the matrix A times B plus B times C. So since the I, jth entry of the matrix this one here is equal to the I comma jth entry of the matrix, this one here, for all I, that is for all the rows. That is, here we, if you see here, we have two rows here and we have 3 columns. So I, we have 1 to 2, and column j, which is column, we have 3 columns, so 1 to 3. So for I, or you can say for 1, for all I 1 to 2, 1 and 2 you can say, and all j, which is 1 to 3. So we have 2 rows and 3 columns, so we write it like that. Therefore A times B plus C is equal to A times B plus B times C. So that's how you checked the property of the matrix multiplication, and that's how you have to write it down in a general form. Or you could just say for each matrix, like you could name these matrices. So you can say that the right hand side here, this one, you could just name it as X maybe, and you could name this one here, the left hand side, as Y maybe, and you can say that you can say that xi comma j is equal to yi comma j. So you can say since xi comma j is equal to yi comma j for all I, which is 1 to 2, and all j, which is 1 to 3. So we have 2 rows and 3 columns. That's how we numbered them. Therefore A times B plus C is equal to A times B plus B times C. And that's the end of the first property.